This is the high-stakes gamble hidden behind the glamorous facade of billion-dollar electric vehicles. Millions of Teslas, Rivians, and Fords will soon need new batteries. The old ones? They are literal urban mines, packed with finite, highly valuable lithium, cobalt, and nickel. You think opening an industrial battery recycling center is a guaranteed ticket to the billionaire class. You just collect the scrap, grind it into dust, and sell it back to the grid at a massive premium. It's green tech. It's ESG compliant. It's a flawless license to print money. Let me shatter that illusion right now. You are not saving the planet. You are managing a ticking thermal bomb. You are entering a low-margin, high-friction commodity trading war wrapped inside a Class 9 hazardous materials nightmare. The average gross margin of an industrial recycling center isn't the 40% tech bros casually pitch to venture capitalists. It is hovering around 8 to 12%. Sometimes it violently swings into the negative. And before you make a single cent of revenue, you are burning $35 million in upfront capital just to turn the lights on. Let's tear down the exact economics of this business, piece by brutal piece. First, let's analyze the surface costs. You cannot run this operation out of a retrofitted warehouse. You are building an advanced hydrometallurgical fortress. Let's look at the capital expenditure for a mid-scale facility designed to process 10,000 metric tons of battery scrap per year. The shredding line alone cost $8.5 million. You cannot just crush a lithium-ion battery in open air. It will explode. You need highly specialized shredders operating inside a sealed, inert, argon, or nitrogen gas atmosphere. Then comes the chemical processing and extraction at $12 million. If you are going the hydrometallurgical route, you need massive corrosion-resistant solvent extraction tanks to leach the metals using sulfuric acid. Add another $5.5 million for environmental control. You are releasing highly toxic fluorine gas and volatile organic compounds from the battery electrolytes. The EPA requires military-grade air scrubbers and effluent water treatment systems. On top of that, fire suppression and safety will run you $3.1 million. Standard sprinklers do not put out chemical lithium fires. They feed them. You need advanced deluge systems, 24/7 thermal imaging cameras, and blast-proof containment bunkers. You also have to factor in permitting and legal fees, which will cost around $2 million as you spend 2 years fighting local zoning boards who do not want a toxic chemical plant in their county. You are $31.1 million in the red before a single battery crosses your loading dock. Then comes the insurance. You are dealing with highly reactive, unstable energy storage devices. The premium for environmental liability and catastrophic fire coverage is not a standard line item. It is a bleeding artery. Expect to pay $850,000 to $1.2 million annually in premiums alone. Next, we need to look at the underground issues. Logistics and the inventory trap. People think you get paid to take dead batteries. Wrong. You pay to acquire them, or at the very least, you pay a fortune to move them. A degraded lithium-ion battery is classified globally as a Class 9 hazardous material. You do not just throw it in the back of an 18-wheeler. Moving it requires specialized UN 3480 certified packaging, Hazmat-endorsed drivers, and strict temperature controls. Transporting 1 metric ton of dead batteries costs between $450 and $900 depending on distance. If a battery is physically damaged or swollen, meaning it is structurally compromised, that cost spikes by 300%. Why? Because you must transport it in individual, explosion-proof thermal containment vessels filled with fire-retardant vermiculite. You are spending 75 cents per kilogram just to drag the trash to your front door. And then it sits in your yard. This is your first hidden cost, the working capital trap. You have millions of dollars locked inside degrading metal boxes sitting in a staging area. If you process them too slowly, your capital is tied up. If you process them too fast without safety checks, your plant burns down. Moving deeper into the operation, let's break down the unit economics and the anatomy of what the industry calls black mass. You discharge the cells. You shred them. You filter out the plastics, the copper foil, and the aluminum casing. What you are left with is the holy grail of this industry, black mass. It is a toxic, graphite-rich, pitch-black powder containing the critical metals, lithium, nickel, cobalt, and manganese. Here is where the microeconomics get vicious. We must look at the math. Let's define the theoretical net profit per kilogram of battery scrap. To calculate this, you take the global spot price for your extracted metals, factor in the severe discount rates that chemical refiners force upon you, account for your physical yield loss, and then subtract every single inbound logistics, operating, capital, and waste cost. Let's break that down with real numbers. Let's say 1 kilogram of raw battery scrap yields 500 grams of black mass. The raw metals inside that mass are technically worth $6.50 based on current spot prices on the London Metal Exchange. Do you get $6.50? Absolutely not. You are producing an intermediate product, not battery-grade pure metal. The downstream chemical refiners who buy your black mass demand a massive discount. They pay you a payable rate. For nickel and cobalt, they might pay 70 to 75% of the market price. For lithium, depending on market saturation, they might only pay 60%. Your theoretical $6.50 just collapsed to $4.55. Now, subtract your 75 cents per kilogram inbound logistics cost. You are at $3.80. Subtract your processing operational expenses. This includes highly specialized labor, massive electricity demands, and expensive reagents like sodium hydroxide and sulfuric acid. That runs roughly $2.10 per kilogram. You are down to $1.70. Now factor in physical yield loss. Physics is cruel. You do not recover 100% of the metals. You lose 10 to 15% trapped in the slag, caught in the HEPA filters, or lost in chemical precipitation. Subtract another 65 cents. You are left with $1.05 per kilogram of operating profit. But wait, we forgot to amortize the $35 million capital expenditure. Over a 10-year period, at a standard 10% discount rate, that's another 57 cents per kilogram. Your net margin is 48 cents per kilogram. 48 cents. If the price of lithium or nickel drops by 20%, which happens routinely on random Tuesdays due to macroeconomic shifts in China or mining gluts in Indonesia, your entire profit margin is vaporized. You are instantly operating at a net loss. You are no longer a business. You are a philanthropically funded hazmat disposal service for automakers. But it doesn't stop there. Beyond the spreadsheets, there are hidden horrors that keep plant managers awake at 3 a.m. The first is the LFP feedstock trap. You sign a contract to receive 20 tons of EV batteries. You model your cash flow, assuming they are high-value NMC 811, containing 80% nickel, 10% manganese, and 10% cobalt. A truck arrives, you shred it. You test the resulting black mass. It's LFP, lithium iron phosphate. LFP contains zero cobalt and zero nickel. Iron is effectively worthless. The intrinsic metal value of LFP is a fraction of NMC, yet processing LFP costs you the exact same $2.10 per kilogram in energy, labor, and chemicals. You just spent $2.85 per kilogram in logistics and processing to extract something you can only sell for $1.10. You just lost $35,000 on a single truckload because you couldn't perfectly sort the chemistry of degrading battery packs before shredding. The second horror is the toxic slag and effluent. Metals are only a percentage of the battery. For every ton of black mass you successfully extract, you generate roughly 1.5 tons of toxic wastewater, contaminated graphite, and chemical slag. You cannot dump this. Disposal of this highly regulated waste costs upwards of $250 a ton. It eats directly into your 48-cent margin. The third is the unforgiving reality of downtime. A single thermal runaway event, a battery sparking and catching fire on the conveyor belt, triggers the deluge systems. The fire is suppressed, but your entire line is contaminated with fire retardant and water. You must shut down for 48 hours to clean, recalibrate, and test. In a facility with a $35 million CapEx, 48 hours of unabsorbed overhead costs you $65,000. You do not negotiate with thermal runaway. Looking ahead, where does this brutally tight economic equation lead? The future landscape of battery recycling is not a fragmented, decentralized utopia of mom-and-pop green tech startups. It is a ruthless oligopoly. The original equipment manufacturers, the Teslas, GMs, and Fords of the world, are not stupid. They see the exact same math. They realize that raw materials are the ultimate bottleneck to their survival. Therefore, they are vertically integrating. In the near future, they will not sell you their dead batteries on the open market. They will mandate closed-loop tolling agreements. Under a tolling agreement, the automaker retains legal ownership of the metal atoms inside the battery at all times. You do not buy the scrap. You do not sell the black mass. You become a glorified high-risk laundry service. They drop off the dirty batteries, you extract the metals, and you hand the pure metals right back to them. They pay you a flat, pre-negotiated processing fee, say $1.50 per kilogram. You take 100% of the operational risk. You handle the acid. You fight the fires. You pay the insurance. They take 100% of the commodity upside. If the price of lithium spikes 500% because of a global shortage, the automaker keeps all the profit. You are locked in at your fixed fee, watching inflation eat your margins alive. Finally, we arrive at the verdict. The revenue chart of an industrial battery recycling center is not a smooth, exponential tech hockey stick. It is an electrocardiogram of a patient in cardiac arrest. It violently spikes with commodity booms and flatlines with supply gluts. The single, ultimate factor that determines who survives and who goes bankrupt in this industry is not technology. It is not having the most advanced shredding blades or the most optimized hydrometallurgical leaching tanks. It is feedstock control and financial hedging. The winners in this space will be the pragmatists who secure ironclad, long-term, fixed-price contracts for inbound scrap, and who ruthlessly hedge their outbound black mass on the commodities futures market. They will lock in their margins no matter how thin and protect themselves from the volatility of the global metals market. The losers will be the idealists. They will play the spot market, absorbing massive upfront capital costs, blindly praying that the green tech hype cycle will inflate lithium and nickel prices forever. In the business of industrial battery recycling, you do not win by saving the earth. You win by mastering the math,